Okay, for example 2, we're going to do something just like we did in example 1. It's just a little more complicated to get it to look in the right form. Remember, the idea is we want this to look like 1 over 1 minus x. And so what I'm going to do is I'm going to start with x over 5 minus 2x. I'm going to start by factoring out an x. Then I get a 1 on top. And then I could factor a 5 out of the denominator. So I'd still have a x out front. And I'm going to factor a 5 out of the bottom. And what that does is it gives me a 1 in this spot. And then this would become a 2x over 5. And that 5 that's on the bottom, I can then factor out to the very front. So this looks like an x over 5. And in the parentheses, I have a 1 over 1 minus 2x over 5. So one way to think about this is I'm not always going to get 1 over 1 minus x, but I want to get 1 over 1 minus something. And that's what I got here. In my box, it's now a 2x minus 5. So that is what I'm going to put in the same way here. I had that negative x cubed, and I put that in for x. I'm now thinking of my 2x over 5 as that value. So first of all, when is this going to be accurate? It's going to be accurate when the absolute value of 2x over 5 is less than 1, because that's when my geometric series would converge. And here I can multiply the 5 to the other side. So I get absolute value of 2x is less than 5, divide both sides by 2, and I get absolute value of x is less than 5 halves. So that is my, I guess you call that my radius of convergence within which this power series representation is going to work. And what is it going to look like? Well, I have this x over 5 on the outside, and then that thing that's 1 over 1 minus blah is going to turn into my sum from n equals 0 to infinity of whatever the blah is, whatever's in the box. Here, that's a 2x over 5 to the n power. And one of the things we like to do with these, I mean, this is technically correct, but it does have this x to the 5th on the outside, and it's also got x's and 5's on the inside. So we typically bring that in. And we get our summation, n equals 0, x over 5. This right here, that's like 2 to the n, x to the n over 5 to the n. And with the x over 5 that I'm bringing in there, I'm still going to have 2 to the n, but I now have n plus 1 x's and n plus 1 5's. So it says, give a power series representation for the function x over 5 minus 2x. That's the power series representation, and it is accurate when the absolute value of x is less than 5 halves. So go ahead and pause the video now and try to do exercise 3, and unpause when you are done or stuck. Okay, so I'm going to start off by factoring out a x cubed out of the top and a 2 out of the bottom. I'm left with a 1 on top, and on the bottom I'm left with a 1 over x squared over 2. So the x cubed over 2, that stays out in front, and then this thing right here, this is difficult. The x squared over 2, that's my box. So I'm getting x squared over 2 to the n, and I want to figure out when that's accurate. And it's accurate when the absolute value of x squared over 2 is less than 1. Multiply the 2 to the other side, and I get the absolute value of x squared is less than 2. And I take the square root of both sides, so absolute value of x is less than square root of 2. And let's finish this off. This is going to be an x cubed over 2. And, whoops, I forgot that I had already written it with the summation. I'm having trouble with the eraser. Oh, and this is always n equals 0 to infinity. N equals 0 to infinity. I bring the x cubed over 2 inside. That x squared to the n is going to go to each of them. So this is going to become an x to the 2n over 2 to the n. What just happened? That is not what I wanted. Let's go back to this one. Oh no, it all disappeared. Drat and blast. Well, let's just finish doing what I was doing. That's unfortunate. I had that it converges when absolute value of x is less than square root of 2. I solved that before. And I was just solving it. I had the sum to infinity at n equals 0 of x cubed over 2 times an x to the 2n over 2 to the n. So I'm basically just adding exponents at this point. This is going to be an x to the 2n plus 3 on top over 2 to the n plus 1 on the bottom. And I'm going to pause the video there because chaos is happening in my house.